Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial guys, we are going to be tackling question 3.1 from the grade 12 mathematical literacy paper 2 that was written in June 2023. And question 3.1 guys deals with measurement, right? We are going to be calculating surface area. We are going to be calculating the volume of the plaster that needs to be applied to this wall. We are going to be calculating perimeter, right? And we're also going to be doing some conversions. Okay, so this question deals with measurement as a whole. We're going to be calculating surface area, volume, perimeter, and we're also going to be doing some conversions. Okay, so without any further ado guys, let's get started with today's video tutorial. Like I mentioned guys, in today's video tutorial we are going to be tackling question 3.1, and question 3.1 guys deals with measurements. Okay, so let's have a look. It says Unati bought a house. Two of the walls in one of the bedrooms were not plastered. Okay, the dimensions of the floor of this bedroom are 4.8 meters by 3.5 meters. Okay, so the dimensions of the floor of this bedroom, do you guys agree that we're looking at this bedroom from top view? So the dimensions are 4.8 meters, that is the length, by 3.5 meters, that is the width, as shown in the diagram below, with a wall height of 2.7 meters. Okay, so we can't see that height because we are basically looking at this bedroom right from the top, so you won't be able to see the height from the top. Okay, so that is why we just see the length as well as width. It says Unati intends on having the walls plastered. Okay, so when they talk about plastered, right, it means that the walls, when they plaster the walls, right, they coat your walls with sand and cement mixture to create a smooth wall surface. Okay, so I'm sure everyone is very familiar with this, right? So if they basically put up a wall, or when they do renovations at home, right, obviously they'll put the wall up with the bricks and then they'll cover those bricks with your plaster. Okay, so that's basically what they're explaining there. Okay, so here we've got the diagram showing the bedroom with the dimensions. Okay, and then these are the two unplastered walls. Okay, so that means that, okay, on this side we're not going to really worry about those sides. Okay, we're just going to be focusing on the unplastered walls. Okay, most especially when we want to determine the volume of the plaster that has to be applied to these walls. Okay, here we're given the pictures of two unplastered walls. So this is like now an actual picture of these walls. Okay, so that's the wall that's unplastered, and then that's the other wall that's unplastered. Okay, we're also given the cornice, right? So when you look up on your ceiling, that's the cornice, okay, that they're talking about, and obviously that is their ceiling. Okay, so it says use the information above to answer the questions that follow. Question 3.1.1, it says calculate in meters squared the total surface area of the two walls that needs to be plastered. Okay, and they've been so nice because they've basically given us the formula that we need to use. Okay, so just to recap, when we're calculating surface area, what are we basically doing? When we're calculating surface area, guys, we are calculating the area, right, of that particular surface that we're looking at. Okay, so if you were to just look at a wall there at home, right, just a plain wall, and I were to say to you, please determine what the surface area of this wall is, right? Then you'd have to then obviously ask yourself, okay, is this wall a rectangular wall? Is it a square, right? In this case, maybe your home, most homes are like rectangular wall, the walls are rectangular, right? So to calculate now the surface area, okay, of that wall, you'll just take the length multiplied by the breadth. Okay, because by doing that we will be determining what the area of that surface of that wall is. Okay, so in this case, right, we want to determine the total surface area. So that is what we're going to be highlighting, the total surface area, right, of the two walls. Okay, so in other words, right, we want to determine what is the area of one wall. Okay, what is the area of the other wall? Okay, and then we're going to add up those two areas together to get the total surface area of the walls that need to be plastered. Okay, so what are we going to use then to determine the total surface areas of these walls? Okay, let's just write down our approach. Okay, so for us to determine the total surface area, right, we will basically take the area of wall number 1 plus the area of wall number 2. Okay, so how can we get the area of wall number 1? So let's basically determine which one are we going to use as our first wall. Okay, so in this case, guys, think of it in a way that you are now in this room. Okay, and when you're in this room, you're not now thinking in terms of top view. You are literally in this room and you are now literally facing this wall, right? Because this is the plastered wall, this is the other plastered wall. Okay, so in this case, let's just deal with this plastered wall, right? You are in the room and you are facing, right, this plastered wall. Okay, unplastered wall, I mean. So what are the dimensions that you're going to see while you're in this room and you're looking at this wall? Do you guys agree that we're going to see that 3.5 meters? What else are we going to see? Do you guys agree that we're also going to see the height of the wall of 2.75 meters? Okay, so when you're in the room, let me just draw this rectangular shaped room for you guys so that you see what I mean. Okay, so we are currently inside this room. Okay, so just picture yourself as being inside this room and we are looking at this particular wall, right? We are given that the distance from there to there, right, is 3.5 meters. Do you guys agree? And what else do you see while you're standing inside this room? You also see the height of this room. Okay, and what was given as the height or the wall height? Okay, the wall height is given as 2.75 meters. Okay, so right now what we're trying to determine is what is the area of this wall. Okay, what is the area of this surface? Okay, so to determine the area of this rectangular surface, you just use the formula that has been given to us, right? The formula that has been given to us is length times width. Okay, so what would be our length? It will be that 3.5 meters multiplied by what is our width is 2.75 meters. Okay, so that is the area of wall number 1. I'll write this as wall number 1. Okay, so the area of wall number 1, we said that it's length times breadth for wall number 1 plus area of wall number 2. It is also still going to be length times width. Okay, so it's length times width, right? Okay, still the same thing, but okay, let's just keep to what is given to us. Length times width plus length times width of area number 2. Okay, and then what was the length? So I mentioned that our length for wall number 1 is 3.5 meters multiplied by what is the width then in this case that we're going to be focusing on. This is our length. Okay, our width is 2.75 meters. Okay, so let's write that down. Okay, plus let us have a look at wall number 2. Okay, so which one is wall number 2? Do you guys agree that wall number 2 is then going to be that wall here on the right? So let me just show you guys. It's going to be this wall. So now we are in the room, right, and we are facing that wall there that I've just indicated. Okay, so let me highlight that wall now. So this is the wall that we are now facing, and we want to determine what is the area of the surface. Okay, so what will help us to determine now the area of that wall or the area of that surface? Okay, we're going to need obviously the dimensions for our length and our width. Okay, so in this case, when we look at the picture that is given to us, what is that distance from there to there, right? So that is 4.8 meters. So when you're in the room and you're facing that wall, you will see that length of 4.8 meters. What else will you see? You will see that height there as you are standing in the room. Okay, so what is the wall height? So that wall height, right, is still that 2.75 meters. Okay, so our length is 4.8 meters multiplied by our width, right, in this case of 2.75 meters. Okay, right, because now you have to think of it in terms of 2D, length times the width. Okay, right, so let's write that down. Okay, and then all that we need to do, guys, remember, we need to show all the bits and pieces. Okay, what is 3.5 meters multiplied by 2.5 meters? Meters multiplied by meters is going to give us meters squared. Okay, 3.5 multiplied by 2.75, that is going to give us 9.625. Okay, meters squared. Plus, okay, 4.8 multiplied by 2.75, that is going to give us 13.2, and then meters multiplied by meters is meters squared. Okay, units are very important, guys. Please remember, because we are dealing with surface area. Okay, when we work with area, guys, let's like us just limiting the 3D aspect of the question. We just want to focus on one particular surface, right? So that's like we're just working in 2D, okay, so to speak. Okay, so in this case, whatever units that you are going to get for area, it needs to be meters squared, millimeters squared, centimeters squared. Okay, units squared. Okay, so if you take 9.625 plus 13.2, right, meters squared, you will get 22.825 meters squared. Okay, so I had one of my learners in my online lessons just asking me how they need to deal with rounding off in the exams. Okay, just remember, guys, with the question, firstly have a look at the instruction page. What is the instructions that are given to you guys in terms of rounding off when you look at the instructions page? Okay, so let's see. What are the instructions that are given in terms of rounding off? Let's see. Round off all final, you see, all final answers appropriately according to the given context unless stated otherwise. So we need to round off all our final answers, okay, according to the given context. So sometimes they will tell you round it off to 2 decimal places. Sometimes they won't tell you how you should round off, okay? So in this case, right, they haven't specified how we need to round off our answer. So you can either leave it like this, right? Or you can just round it off to 2 decimal places, okay? But I prefer that we just leave it like this because you'll see that all questions actually just follow from this first question. So I'm going to leave the answer as 22.825 meters squared, okay? Because they were not really specific in how we need to round off this particular question, all right? So let us have a look at the next question. Okay, so that is the area, the total surface area of these two walls. Okay, of these two walls. That wall and this wall combined, right, their surface areas is 22.825 meters squared. All right, let's have a look at the next question. Question 3.1.2. It says the plaster on the walls has a uniform thickness. Okay, so they're saying that when they plaster now these walls, it will have a uniform thickness. The thickness will be the same for both these walls. Okay, we want to determine in centimeters cubed the volume of the plaster required to plaster these two walls. Okay, so we want to basically determine how much plaster, okay, is going to be put into these unplastered walls, right? If we are told that these walls, when they plaster them, they need to have a thickness of 12 millimeters. Okay, so the keywords in this question, right, is that we are calculating volume, all right? And when we're calculating volume, we've got length, we've got width, and we've got height. Or we can even say we've got the area, multiplied by the height, or we can even say that we've got the area multiplied by the thickness. Okay, so in this case, because we've already calculated, okay, the areas, the total surface areas of these two walls, right, for us to be able to determine the volume of the plaster that will be required, we can just multiply that area, the total area that we've obtained of 22.85 meters squared, by the thickness. Okay, and that will give us the volume of the plaster that is needed. That is one way that we can look at it. Another way that we can look at it, right? Another way is that I like breaking things up, right? So here we can just think that, okay, when we are calculating volume, remember I spoke in the other video tutorials, when we're calculating volume, guys, okay, in this case, we are not really calculating how much space is enclosed in a particular object, right? We're just trying to determine if we were to put a particular plaster on this wall, right? What is the volume that would be needed for this plaster? So try to think of this wall, think of this in 3D, okay? So obviously we want to now plaster this wall, right? And to plaster this wall, right, we already know the dimensions from there to there, okay? We're already given that was 3.5, right? We already know what the height is, and the height was given as 2.75 meters. And we want to determine the total plaster that will be now placed on this wall. Okay, so for us to be able to determine that total plaster that will basically be put onto this wall, that's the plastering that we want to put onto this wall, right? Okay, I'm just trying to show the thickness. Okay, so if we already know that this is 2.75 meters, okay, and we already know that from there to there it's 3.5 meters, okay, and we know that we just need a thickness, right? That is the thickness there, okay, of 12 millimeters. Okay, we can actually determine the volume of the plaster that will be needed to put onto this wall. Okay, so it's kind of hard for me to draw that so that you guys see what I mean, but then that is the thickness, because it's gonna stop there, and then that's now the plaster that they put onto that wall there. Okay, so how will we go about now determining the volume of the plaster? We already have the 12 millimeters, we've got the 2.7 meters that shows the height, and we've got the 3.5 meters that shows the width, right? So to calculate the volume, guys, we know that total volume, okay, how do you calculate volume? Okay, that basically means that we will calculate the volume of that will be needed for wall number 1 plus the volume that will be needed for wall number 2, right? And then how do we calculate volume? Remember, guys, okay, we said that volume is equal to area, right, of the base, area of the surface, in this case, multiplied by the height, or multiplied by the thickness. Okay, so here we already know what the area is for that whole wall, and we found it by taking 3.5 multiplied by 2.75, and we just need to multiply it by the thickness, so that thickness of 12 millimeters. Okay, so now the thing that's very important that we need to do here now first is we need to convert. We first need to convert all these units, right, into centimeters. Once we've converted the units into centimeters, then it'll be easy for us then to substitute everything into our formulas. Okay, so let's just quickly do the conversions, right? So I'm just taking the longer route so that you guys can see, but I'll also show you guys just the quicker way to apply this concept if you really understand what's happening. Okay, so we're just going to convert that 12 millimeters. Okay, so remember, guys, when you're doing our conversions, always just have this diagram at the back of your head. I always emphasize this with the learners that I tutor. Always just even draw the diagram quickly. It's not even going to take you more than 10 seconds. Okay, and then from there you won't make any silly mistakes when you're doing your conversions. Okay, so remember, we are moving from millimeters and we want to go to centimeters. Okay, so we know we've got kilometers, it's meters, it's centimeters, it's millimeters. Okay, we are moving from a smaller unit to a bigger unit. So in this case, we are just going to be dividing by 10. But at this point, if you've been watching all my video tutorials, guys, you know that I just draw this diagram each and every time. Okay, so you should understand what's happening at this point. Okay, I was also impressed when I noticed that my learners actually apply this concept. Like the learners that I also just tutor, they really do draw these diagrams and it helps them a lot. Okay, so we are converting that 12 millimeters into centimeters. What do we need to do? We are currently here at millimeters. We want to go to centimeters. So what are we going to do? We are just going to take that 12 millimeters, right? And we are going to divide it by 10. Okay, so that's 12 millimeters divided by 10. That is going to give us 1.2 centimeters. So that is our thickness. Okay, so we already have the thickness. Okay, what else did our formula say? Remember, we said that volume is equal to the area multiplied by the thickness. So here, guys, we already calculated the area of wall number 1, right? I'm going to highlight it in red. We already calculated that area, so we don't have to calculate it again. We've already calculated the area of wall number 2. Okay, so we're going to be using those areas to help us get to the volume. However, what do we notice about the units of measurements there? It's in meters squared. However, we want our final answer to be in centimeters cubed. So how will we now convert meters squared to centimeters squared? Okay, so that's a very important concept that I want to talk about in this video tutorial. So that is why I've chosen this direction in terms of explaining. Okay, so when we want to basically move from meters squared, right, to centimeters squared. Okay, so we want to move from unit squared, one unit squared to another unit squared, right? Just also think about this diagram that we've just done here. Okay, the only difference is now we are actually dealing with kilometers squared. Do you see that? Meters squared, centimeters squared, millimeters squared. Okay, so now if you want to basically convert your unit squared, right, you can just also square it in your diagrams. So if you're just basically squaring there, right, that means that this 1,000 also needs to be squared. This 100 also needs to be squared. This 10 also needs to be squared. Same here at the bottom. Okay, so that basically makes our life super easy. We just want to now convert that 9.625 meters squared, that area of wall number 1, into centimeters squared. So that means that we are currently here, right? And we want to move to there. So what do we need to do in this case? Okay, so for wall area, for wall number 1, is just going to be that 9.625 meters squared. We want to convert these meters to centimeters squared, okay? So we want to move from meters squared to centimeters squared. So what are we supposed to do? You multiply it by 100 squared. So you're going to multiply it by 100 all squared. And that will give us our units in centimeters squared, okay? Then same here, area of wall number 2. Okay, we are given 13.2 meters squared. We are currently here. We want to move to there. So you multiply it by 100 squared. Okay, so if you punch this into your calculator, 9.625 meters squared multiplied by 100 squared, that changes those units to be in centimeters. Okay, so your answer will be 96250 centimeters squared. Nice, done. Okay, how would we basically convert this one? 13.2 meters squared, same thing, 13.2 multiplied by 100 squared. Answer is 132,000 centimeters squared. So now we are more than ready to basically substitute these values into our formula. We know that to get the total volume, right, we're just going to take total volume. Okay, let me just do it here. It's going to be equal to the volume of wall number 1 plus the volume of wall number 2. How do you get the volume of wall number 1? You just take that area of wall number 1 multiplied by the thickness plus the volume of wall number 2. Same thing, the area of wall number 2 multiplied by the thickness. So that's all that we're doing. Okay, so here, let's do that. So the area of wall number 1 is 96250 centimeters squared multiplied by what was our thickness? Remember, we converted our thickness into units, into centimeters, right? So it is 1.2 centimeters plus. Okay, area of wall number 2, it's 132,123 centimeters squared multiplied by the thickness of 1.2 centimeters. Okay, if you punch this into your calculator, you'll get that the volume of wall number 1, okay, is actually equal to 115,500 centimeters cubed plus volume of wall number 2, 158,400 centimeters cubed. If we add these two values together, you'll find that then the total volume, okay, of the plaster, okay, total volume of the plaster, right, is actually equal to 273,900 centimeters cubed. Okay, so that is basically how we can basically approach this question the long way. Okay, the short way, okay, is that we already know, remember, okay, we've already calculated the total area of the two walls, okay, and we found that the total area of the two walls is 0.825 meters squared. Okay, so here we're gonna obviously just say we're gonna start off with that total area of 0.825 meters squared, and then all that we want to do now is that we want to convert this area from meters squared to centimeters. Okay, so same thing that we're doing here, right? We want to move from meters squared to centimeters squared. Okay, how do we do that? You multiply by 100 squared. Okay, so you're gonna just multiply it by 100 squared. Okay, squared, please, 100 squared. So if you multiply it by 100 squared, okay, you'll get 228,250 centimeters squared. Okay, therefore, to get now our total volume, that'll just be this area that we've calculated in centimeters squared of 228,250 centimeters squared multiplied by the thickness, right, of, remember we said that the thickness is 1.2 centimeters. Okay, so it's 1.2 centimeters. Okay, so if you punch that into your calculator, okay, you'll get 273,900 centimeters. Centimeters times centimeters squared times centimeters is centimeters cubed or cubic centimeters. Okay, so that is also your final answer. So you can approach these this question either like this, right, or like this. Okay, so I was just breaking it up just so that you guys understand what is happening with just the first part. All right, okay, so we are done with question 3.12. Let us have a look at question 3.1.3. It says the ready mix plaster is available in bag. One bag is needed for every 15,000 centimeters cubed. Okay, so in other words, what is this sentence telling us, right? This sentence is just telling us that one bag is needed, right, for every 15,000 centimeters cubed. So we can write that statement as an equation. One bag is equal to 15,000 centimeters cubed, or one bag is needed for every 15,000 centimeters cubed. This is going to help us now when we have to then maybe determine what is the minimum number of bags that are needed to plaster the two walls. So we're going to use this equation to help us get to that answer. So we've already established that now the volume of the plaster, okay, that is needed, okay, for this wall is 273,900 centimeters cubed. That is the total volume of the plaster needed. Okay, so if we already have what the total volume is, right, and now we want to determine the minimum number of bags needed, what do we need to do? Do you guys see that now we can use this equation to help us determine how many bags we will need? Okay, we already know that, okay, the total volume of the plaster needed is 273,900 centimeters cubed. And then we know that one bag is needed for every 15,000 centimeters cubed. Okay, so we want to determine if we need a volume of that amount, how many bags will we need? We can literally use this equation. Another person can see that you can just take the 273,900 and you divide it by 15,000 centimeters cubed, right? And then you'll notice that the centimeters cubed and the centimeters cubed will cancel, and whatever answer that you're going to be getting is going to give you the amount of bags that you'll need. Or another person will want to use my approach that you multiply by what you want, which is we want how many bags will we need. So I'll just write we want how many bags, right, divided by what you have, okay, which is the units in centimeters cubed. Okay, so that's just 15,000 centimeters cubed. Okay, so from there, okay, you can just see that that's the same as just taking the 273,900 centimeters cubed divided by 15,000 centimeters cubed. Okay, the centimeters cubed will cancel. Whatever answer that you get here tells you how many bags you will need. Okay, so if you take 273,900 divided by 15,000, you'll get a value of 18.26 bags. However, guys, we are working with a real life situation. You want to literally go get these bags. You are not going to come back with 18.26 bags. Okay, so we want to be realistic in our answer. Okay, so that means that you want to get approximately 19 bags. You're not going to get 18 bags in this case, because if you get 18 bags, you are going to be short of 0.26 material. Okay, so that is why here we round up so that you do not become short in terms of your bags. Okay, so the final answer for this question is that you need a minimum of 19 bags. All right, cool stuff. Let's have a look at the next question. Question 3.1.4, Unathi would also like to have all the old cornices in the bedroom where the 4 walls meet the ceilings replaced. Calculate in meters the total length of the new cornices. Okay, so the nice thing here is that even if you do not know what a cornice is that they've basically shown you here in the picture. That is our cornice there. Do you see that? Okay, that part there, that is our cornice. That white part, that is the cornice. Okay, so they're basically saying that Unathi wants to replace these cornices, right? So if you think about a ceiling and you look up and you see the cornice going all around the wall, all around the ceiling, right? Now we understand what this question is asking us to do, right? It's basically asking us to calculate the total length that is needed of the cornice. So if you calculate the length of the cornice from one side to the other side to the other side and the other side, you calculate all the sides, right, of the cornices, all the lengths of all the sides, and you add them up together. That is what the question is basically asking you. Because when we are determining perimeter, we want the total length of the outline of the shape, of the boundary of the shape. Okay, so that is what we are doing here. But nicely, they've just given you the formula that you need to use. It's perimeter is equal to 2 times length plus width. So we're going to use that formula. Okay, all that we now need to determine is what is our length and what is our... Okay, so in this case, even when you're just looking at the top, right, the cornice is just the outline of these walls. Do you guys agree? Okay, so in this case, the length will be 4.8. The width will be 3.5 because the cornice is just going all around this wall. Okay, so the length will be 4.8 and the width will be 3.5. Okay, so what is 2 times 4.8 plus 3.5 gives us 8.3 meters, because we're just adding meters plus meters is just meters. We are not multiplying, okay? So it won't be meters squared. Then 2 times 8.3 meters is 16.6 meters. All right, so the units, remember, for perimeter, it's units, meters, kilometers, centimeters, millimeters. Okay, so that is basically going to be our final answer. So I hope you guys enjoyed this video tutorial, guys. It was slightly a bit long because I decided to break up certain components of this question, but I'm hoping that it just makes sense for everyone, because I just want everyone to leave these video tutorials with just understanding what you guys are supposed to do, right? Just breaking it up and just helping you guys see how you can apply this these concepts to even questions where it just looks like a bit too much to handle. Okay, so that is it for today's video tutorial, guys. In the next video tutorial, we are going to be tackling question 3.2, and question 3.2 deals with probability, guys. With probability, you just need to be able to apply the complementary rule. You just need to be able to calculate probability using the formula probability is equal to favorable outcomes divided by the total outcomes, and you need to be able to interpret the probability scale. Okay, so this question is nice because it has just summarized everything that you need to know when it comes to probability. Okay, so I'll see you guys on my next video. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.